Hello and welcome everyone to online meeting and presentation on moisture management of transformers. It will be presented by me, Mubarak Khan. What is a transformer? We will directly start with the technical session without any further delay. So what is a transformer? A transformer is the most expensive equipment in the power supply chain. It is used to transfer electrical energy between two circuits. It is used in power generation, transmission, distribution and the industries. What is a transformer? It contains of thin steel plates and copper winding, and then we have a transformer tank. We have bushings and other accessories. Now, if you closely analyze the transformer, most of its parts are metal, right? So most of its parts are metal, so they are not perishable. They don't get consumed over a period of time. But there are two components in a transformer which are perishable, which are not metal. It is transformer paper and transformer oil. Okay, these two things are used for as an insulating medium, keeping the live circuit away from the earth or from the body. Okay, so these are the two main components. But the issue is these insulating materials have their own life, so they have an end of life. Correct. Oil, of course, immersed in paper has an excellent insulating properties and is used for cooling down the transformers. Oil and insulating paper both contribute to the factor known as breakdown voltage, right? What is a breakdown voltage? The voltage at which the current may pass through the insulation of the transformer. So it is a breakdown voltage where I'm just trying to explain in a layman fashion, and therefore the safety of the transformer, because if there is a flash, it can cause a hazard for the transformer. Okay, breakdown voltage indicates how well the insulating oil can withstand the electrical load. Okay, so these are the different parts of the transformers as we discussed. Now we are taking a thought. We will consider two important parts because they are the things which contribute to the life and the safety of the transformer. These are paper and oil. Okay, first we start with the paper. The transformer life expectancy is directly linked to the status of insulation cellulose paper, right? The paper quality is defined by the factor known as degree of polymerization. It represents the average length of cellulose chain. If you understand the chemistry, the set of molecules connected together makes a cellulose chain. Over a period of time, this cellulose chain, it breaks because of various factors. And this is the reason it is said that the degree of polymerization is reducing. Okay. For a new transformer, the degree of polymerization is between 1200 to 1000. It is approximately that range. At the end of the life, the degree of polymerization is around 200. So we can say that the age of the paper, the age of a transformer or the age of the paper is the time taken by the degree of polymerization to reduce from 1200 to 200. So if with some technique we are able to reduce this rate of reduction of degree of polymerization, we will be able to increase the life of the transformer. I hope this was not too technical for everyone, but anyway, let's continue. Decrease can be fast or long or slow depending on the life conditions, similar to humans. We humans, when we live, definitely we are bound to have a long life or a short life depending on the conditions we are subject to. And similarly for the transformers, what are the different conditions of the transformer which affect the life of the transformer? They are temperature, acidity, moisture. What is the temperature from? Temperature is because of the load, right, and the ambient temperature. And then acidity. Acidity is formed inside the transformer from the normal operation process of the transformer. So it is formed inside the transformer oil itself. Then is the moisture. Moisture, it comes from outside also, and it is formed inside the transformer also. Okay, so these are the various factors which affect the life of the transformer. So now in the image you can see the new which is marked, that is a new paper, which is a full paper kind of paper. And then when the paper becomes old at the end of life, you will see it will just break into pieces, or it will just become like a powder. If you may have observed, if you have kept paper under the soil for certain years, you will see that paper, it will become very thin, or it will break. It will, like, the paper will break and it will into bits and pieces. That is what happens to the transformer paper also. Okay. So moisture in a transformer, where does it come from? Where is it, and how to quantify its volume? So as we saw, the temperature is because of load. So definitely that is the normal operation of the transformer. We cannot do much about it. The acidity is formed inside the transformer with the normal operation and the function of the transformer. So we can do something about it, but not much. Okay, because it will always be there. We can do the filtration and removal of the acidity, and there is a moisture. So if we are able to improve the life conditions, we will be able to improve the life of the transformer. Now we are going to focus on how to cater to the major issue, which is the moisture. Okay. So let us discuss, where does the moisture come from, where is it, and how to quantify its volume. Where does the moisture come from in a transformer? It comes from the tank, of course, right? 60 to 70% of the moisture is coming from the breather, and 30 to 40% of the moisture is formed within the transformer by the normal depolymerization of the transformer. Okay, so the moisture source is external as well as internal. Ingress through the breather. The more the load is changing, the more there is exchange of moisture from outside. Therefore, more risk of ingress. If outside air is very humid, then it is hard to remove it to 0%. Okay. Silica gel capability is not 100% definitely. So whenever it is exchanging air from the outside, it will absorb some of the moisture and it will let some moisture go. So that is why there is always some moisture which is coming inside the transformer through the breather. It also varies with temperature. At high temperatures, the efficiency of the silica gel is low. Okay. The second cause of moisture production is the paper depolymerization of the paper. Somebody's I'll request everyone to mute, please mute yourself, and you unmute yourself only if you have a question. Mostly we will cover the question answers during the question answer session. But if there is anything which is critical to understand now, you can unmute and ask. Okay. And if you are not able to hear my voice properly, or you have any issues with my accent or anything, you can ask me. Okay. So I will continue. Moisture, where does it come from? Okay. So as we saw from the silica gel, and the second cause is the paper depolymerization. Means the moisture is produced within the transformer. Under the normal life of the transformer is subject to moisture, ambient atmosphere, and temperature because of loads. I request the host to mute everyone, please. Not me, please, but everyone else. Uh, so the paper is subject to three important factors: moisture, ambient atmosphere, and temperature. Okay. Because of these three factors, the cellulose chain it breaks. When the cellulose chain breaks, the byproduct of the chemical reaction is carbon monoxide, carbon dioxide, and water. Normally, the carbon dioxide and carbon monoxide are mixed in the dissolved gases. And if in the DGA data you get an information that you have more carbon dioxide and carbon monoxide, it may be an indicator that your paper is aging fast. Okay? This is one factor. Then the third thing which is being produced is water. Water, because it is a liquid, it does not get dissolved inside the dissolved gases, but then it gets absorbed in the paper. So some amount of moisture it remains in the oil, and some amount of moisture it goes to the paper. This moisture, when it goes to the paper, because it is one of the factors for paper depolymerization, it causes further degradation of the cellulose paper. It causes further breaking of cellulose chain, and it produces more water. Okay. So water is the cause of paper depolymerization, and water is the product of paper depolymerization. Because of this, it becomes a cyclic effect, and as more water is produced, it causes more acceleration. So it causes accelerated aging of the transformer paper. There is a question, what should be the BDV value that we will say oil is deteriorated for 10 MVA transformer along with BPM value? I will reply to this question at the end of the session, please, because it will just divert from the topic. Okay, I will definitely reply to this question, but at the end of the session. Okay. So now we have seen the paper is causing depolymerization. The paper depolymerization is causing production of moisture, and the moisture is causing further degradation of the paper. So as we saw, there are two ways in which the moisture can come inside the transformer. That is one from outside and one from inside. Inside the transformer, the total amount of moisture, 98% is being absorbed in the paper, and only 2% of moisture is in the oil. Very important to remember this factor, because I am going to cover some more details on this particular part. Okay, so just to understand, as of now, 98% of moisture in a paper, in a transformer, is in the paper, and only 2% of the moisture in a transformer is in the oil. Okay. Moreover, when the load increases, the temperature increases and the moisture absorption capacity of the oil, it increases. So there is an exchange from moisture from the paper to oil. Paper to oil. The moisture goes from the paper to oil when the load increases or the temperature increases. Okay. Similarly, when the load decreases, the moisture absorption capacity of the oil reduces. So at that time, there is an exchange of moisture from the oil to paper. The moisture goes from the oil to paper. So during this transition period, there is an exchange of moisture. Now I just want to point out one important factor, that we are taking oil samples, right? We are taking oil samples frequently for a transformer, correct? Now, when you are taking the oil samples in the transformer to check the moisture, is the load of a transformer always steady? No, it is varying. Sometimes it is something is switching on, something is switching off, and the loads are varying continuously. What it indicates that your moisture in a transformer is never in an equilibrium stage. It is never in. Sometimes it is getting transferred from the paper to oil, and sometimes it is getting transferred from the oil to paper. What it means that in a transformer, if you take the oil sample and check the moisture, you are not 100% sure that whatever moisture is there, it is the actual figure. It can change tomorrow because the transition period is very long. Okay, so that is why offline sampling often does not give you correct results. I'll cover this more in detail in further slides. Secondly, moisture in a transformer is dependent on the temperature. At the higher temperature, the moisture in oil will be high. At lower temperature, the moisture in oil will be low. Definitely, the moisture will not go anywhere. It will just get transferred to the paper. That's it. So whenever you check the ppm, you will get low ppm at low temperature, higher ppm at high temperature. So the more the oil is warm, the more water is soluble in it. The temperature and ppm curves in a transformer are following each other. Now, how to quantify its volume? Like how much is more? We have seen where the moisture is and all these things. Now we'll see how much moisture is more. That is also very important, because if you call somebody an old man, you should know what old means. Old means above 40 or above 60 or above 90, right? So in the similar way, moisture in a transformer, we should know what is the limit and how much moisture we will call less and how much moisture we will call more. So as per various international standards like SIGRE, IEEE and IEC, they have given various guidelines for the status of moisture. We will just discuss the SIGRE. So as per SIGRE, less than 1% of moisture in a transformer is considered as a good or a new transformer. Okay. From 1% to 2% of moisture in a transformer is considered as a dry transformer. From 2% to 4% is considered as a wet transformer, and above 4% is considered as excessively wet transformer. Okay. So these are and other standards also have similar indications. So from these explanations, we understand that one thing is very important, that any moisture above 2% is not good. It is wet or excessively wet or whatever. It is a wet transformer about 2%. So we will take our margin as 2% for new transformer less than 1%, and for old transformers, good the dry means below 2%. Okay, that is our limits. Above 4% is excessively wet. Now we'll try to quantify the volume. How much moisture is there in a transformer? So 1 ppm. 1 ppm means 1 parts per million, means 1 liter of water in 10 lakhs liter of oil. Right? 1 million means 10 lakhs. It is crucial to link this value with the oil temperature. As we saw, the temperature and moisture curves, they follow each other. So when the temperature increases, the ppm will increase with the same amount of moisture in a transformer. Okay, so that is why it is very crucial to link the ppm with the temperature. Then you will see the equilibrium curve to define the water content in the paper. So what we will do is, we will, yes, somebody wants to say something. So what we will do is, we will try to find the ppm, how much ppm is there and at what temperature, and then we will, from that we will try to calculate how much moisture is there in the paper. Okay, so I will just ask one question to all the audiences. What is worst, 25 ppm at 70 degrees Celsius or 12 ppm at 40 degrees Celsius? This is a question to all. I will wait for some time. Please reply.
Yes, sir.
25 ppm at 70 degrees Celsius, 12 ppm at 40, equally bad. 12 ppm at 40 degrees Celsius. Okay, so we have mixed responses from Riyaz sir. It is 25 ppm at 70 degree. From Mr. Ram Sheikh and Mr. Abhinav, it is 12 ppm at 40 degrees Celsius. Mr. Sudhir is saying that it is equally bad. So the chat is coming to everyone. Very good. So thank you for the responses. I'm really happy. So many people are responding. That means you are really listening to what I'm saying and you are understanding what I'm trying to say. Okay, so thank you very much for the replies. We are getting multiple replies, and all majority of the reply is 12 ppm at 40 degrees Celsius. So we will try to. I'll not reply to this question. I will just directly. We will do the calculation and we will find out. Okay. Krupa, yes, thank you, Sunil sir. Thank you. So we'll just try to calculate. Okay, so the Irfan. Okay. Now what is worse? So we will try to see. So as we saw in the previous slides, the maximum moisture in a transformer is there in the paper, not in the oil. Only 2% of moisture is there in the oil, and 98% of moisture is there in the paper. That means no matter how much water is there in the oil, it doesn't matter, because majority will be there in paper. So we need to find out how much moisture is there in the paper, not in the oil actually. Okay. So at different temperatures, as we saw the transition period, at different temperatures, the moisture exchanges differently from the oil and the paper. Okay. So we will analyze this thing, this 25 ppm at 70 degree at the temperature which is mentioned. Okay. So this is a graph which is known as the moisture equilibrium curve. It is available in various standards, and various people have given different guidelines. They have some curves here and there, but mostly they are similar. Okay. So in this particular graph, on x-axis we have ppm, and on y-axis we have percentage moisture in paper. Okay. And then we have different curves for different temperatures. Okay, we will plot this graph. So now I think there is pointer function is there in this. No. I think no, there is no pointer function. Okay. So we will plot this graph virtually. So 25 ppm at 70 degree means 20 and 30 is here. So somewhere here it will be 25, and temperature is 70, and this is a 70 degree curve. So 25 ppm at 70 degrees somewhere here is coming to 1.6% of moisture in paper. 1.6%. Okay. This one says 1.6%. Now coming to 12 ppm at 40 degrees Celsius. The 10, and here it is 12. Somewhere here it is 12. at 40 degree means this is the 40 degree graph. So 12 ppm at 40 degrees Celsius means around 2.7% of moisture in paper. So among the two, 12 ppm wala is more and it is more dangerous because at low temperatures the ppm in the oil will be low. I will take an example of a transformer which is kept idle for some time. If the transformer is kept idle for some time, the temperature of the oil will be equal to the ambient temperature. The transformer will not be hot. Okay? At that time, even if you are getting low ppm values, it doesn't mean your transformer is healthy. You need to compare it with the temperature. Okay. So unless you know the temperature, you can never say. Good afternoon, Prajwalji. You can never say that your ppm is high or low unless you know the temperature. Okay. So now, as per the comparison, this is 2.7%, this is 1.6, so definitely 2.7 is more. Now this 2.7 is as per Segre graph, it is more than 2%. So as per Segre, it is a moderately wet transformer. Okay. So in both cases, it is not good. Now we will try to analyze in this particular scenario 12 ppm at 40 degree, what is the actual amount of water in a transformer. Okay, we'll just calculate that. Now we already know in a transformer we have ppm means parts per million, means if it is 1 ppm means it is 1 divided by 10 lakhs, right? So we will compare the actual weight of the oil and paper with the ppm value. So we take an example of a 36 MVA transformer with 15,000 liters of oil, which is approximately equal to 13.2 tons. Okay, then we have 1.5 ton of cellulose insulation. This is an example. Mostly a transformer of this size will have this much amount of oil and paper. So the figure was 12 ppm at 40 degrees Celsius. That was the average oil temperature. 12 ppm of water in oil means 12 parts per million, means 12 divided by 10 lakhs multiplied by the total weight of the the oil, right? Which will come to approximately 0.16 kg of water, which will be approximately equal to 0.16 liter of water. What it means that 1 glass of water. 12 ppm at 40 degrees Celsius, we are saying it is in the dangerous scenario, right? We said it is in the dangerous scenario. It is a big transformer, 36 MVA, but if we calculate it, actually it is only 1 glass of water inside the transformer. Is it more? No, it is not. Ek glass mein kya hota hai? Nothing, right? Now, when we compared with that percentage of moisture in paper, okay, it came to be 2.7% of moisture in cellulose. 2.7% means 2.7 divided by 100 multiplied by total weight of the cellulose paper, which will come to approximately 40.5 kg, which is approximately equal to 40.5 liters of water. Now 40.5 liters of water means 2 buckets of water. This becomes very dangerous. Okay, so that is why if you compare now again, only 0.16 liter of water in oil and 40 liters of water in paper. So definitely the ratio is very high. Again, this is why we said that around approximately 98% of the moisture is in paper, only 2% is in oil, and this is how we do it. Normally by offline filtration system, we are removing the moisture in oil, but the moisture in paper, it remains there. You are not able to remove it. That is why every few months you have to do it again. Okay. Why is the moisture a concern for a transformer? This we already know. People have faced, learned, and everything. But we'll briefly cover. It concerns with the safety of the transformer. The breakdown as the breakdown voltage decreases because of the transformer, right? This moisture in the transformer. Correct. The more water is concentrated in the oil, the breakdown voltage will reduce more. Right. Moreover, during the time of exchange of moisture from paper to oil and oil to paper, at that time the BDV drops further, very rapidly it drops down. Okay, that is also a very risky scenario during the transition period. So the direct calculation of BDV is through this curve, but this will not work because during the transition period, the scenario changes. And as you know, the transformer is never in equilibrium. There is always exchange of moisture from paper to oil, oil to paper. So that is why the BDV from because of moisture will be significantly down. If you take the oil sample, you check the BDV, it may not be so low because sample is in the stationary state. But inside a transformer, it is not in stationary, it is moving. Okay, and moving molecules, they carry more current. That is why the BDV drops. Now, life expectancy of the transformer. As the moisture increase of 1% in the paper, means from 1.7 to 2.7, a moisture increase of 1% in the paper is doubling the depolymerization speed. We can easily compare it with the sugar. Only small amount of increase in blood sugar can reduce the life of the person. Similarly, a small increase in the percentage of moisture in paper is doubling the depolymerization speed. It is reducing the life of the transformer. Every 1% extra moisture will reduce the life expectancy by a factor of 2. Okay, we'll just try to explain this with an example. An example is taken of around same two identical transformers placed next to each other. Okay, and age of both the transformers is around 30 years. They are both placed and subject to same conditions. Okay, same load, nothing is different from the two transformers. Now, at one point of time, somebody came to you and explained that, yeah, you should use an online drying system for this transformer. Okay, you should remove the moisture from a transformer, make it from 2%, make it 1%, or from 3%, make it 2%. Okay, somebody explained it. You said, okay, we will do it, but we will install it in only one transformer, not both. We'll analyze the performance. What will happen is the transformer at the age of 30, the transformer without the drying system will have an end of life at around 40 years. The transformer with a drying system, it will have an end of life at around 53 years. So we will get additional 23 years of residual life, means 13 years life is increased. Only ye last minute you have applied it at the end of the life. Then you have increased the life of the transformer by 30%. Okay, so this is the advantage of reducing the or maintaining the ppm level or maintaining the moisture in paper to a lower value. Okay, now this was one. Now we will see in more detail for a new transformer. We take a same transformer example and we have taken a new transformer. In a new transformer, in one transformer you have installed a system which ensures that your moisture is not increasing beyond a certain value. For example, 2%. Moisture is not increasing above 1.5%, for example. And one system you have installed in which you have not installed any monitoring system or any drying system. Okay. If you compare the life expectancy of both transformer, the transformer without the continuous water extraction system will have a shelf life of around 35 years. Then comparatively, the same transformer with a continuous water extraction system will have a shelf life of 60 years. You see, it is almost 40% increase in life. Okay. Now, here I want to make a statement which is mentioned on the slide also. As moisture is created continuously and as it is a major concern for the transformer safety and life expectancy, it seems counterintuitive to apply a temporary solution for this continuous problem. What it explains that for removing the moisture, we are using a periodic moisture removal system, which is periodic. But since the moisture is produced inside the transformer continuously, we should try and implement the online moisture extraction system, not a periodic. Okay. Now, how to monitor a moisture? See, we have seen a lot about the moisture in a transformer today. We'll see how to measure it. Normally, we are doing through samples, right? But because, as I explained, again, the transition period, the moisture in a transformer never reaches equilibrium. So, at every different instances, whenever you are measuring the moisture, you will get a different value. So, here in the graph, it is shown that moisture, because of the large amount of hysteresis in exchange of moisture from paper to oil and oil to paper, at whatever instant you are checking the ppm value, you will not get the same. Okay, and as per analysis, they have noticed that with the same amount of moisture in a transformer at the same temperature, people have got different values at different instances. Even these values are varying in the range of 20 ppm. Okay, So that is why offline testing will not give you the exact values of the ppm. Now secondly, we have already seen the moisture equilibrium curves and its effect. So it has a very complex dynamic behavior in a transformer. Then a constant moisture monitoring is required because it does the analysis and summing up all the values. And because see, if you measure at one instant, the values will be different. If you measure tomorrow, value will be different. But if you measure for continuously for 1 month, for example, you will have variations, but you will have a mean curve also. That mean curve will give you the exact behavior of the moisture in the transformer. Okay. That is why what I point I want to make is we need continuous monitoring, not a temporary or portable. What are the solutions to dry a power transformer and when to use them? We will see this. And monitor also, of course. We'll see monitoring afterwards. First, we'll see the how we can remove the moisture from the oil. So there are two main methods which are very popular in the industry, which is offline oil drying through oil filtration machine and vacuum drying, right? Okay. We have some questions in the chat. I will answer at the end of the session. It's better to answer that time. Thank you for see. I really appreciate people who are putting the questions in the chat now, because it is good. At the end of the session, we can take the questions directly. Okay, so if you have any questions, just put it in the chat. Later on, I know you will forget, so it's better to put it now. Okay, what are the solutions to dry a power transformer? Oil drying and vacuum drying. We will see one by one. So oil circulation method, it is an offline, online or offline process. Some people do it online also, but it is not so good because it disturbs the normal oil circulation of a transformer for cooling purpose. Right, several thousands of liters of water oil is exchanged at very short time. Advantages: it is very low cost. It is a simple technique and it requires a low operating expenditure. What are the disadvantages? It does not dry the paper. Okay, so it is a drying method, but it does not dry. It's like counterintuitive, because this only dries the oil. Okay, it only dries the oil. Now, why it is not drying the paper? Some people claim that it is drying the paper and they are trying to circulate it for some time and remove it. But as you know, the equilibrium condition or the time taken from the moisture to come from the paper to oil and go from the oil to the paper is very large, right? So in a short time, it is not possible to remove the full moisture from the paper. At least how much it is required, it is not possible to remove it. So that is why nobody can claim really that they have dried the paper properly. That is why we get frequent requirements of offline drying. It disturbs the natural oil flow of the transformer for cooling purpose and for that. Online operation cannot be maintained for long days. We need to put it on and then we need to switch it off. Okay, it disturbs the dissolved gases. It removes some. It adds some new gases. So the DGA data which you are using for diagnostic analysis of a transformer is lost. So you cannot really rely on a DGA data of a transformer whose you have done filtration recently. Okay, so that is why this is very important and very risky factor. Long drying times, it requires very long drying time, and we need to dry it very frequently, and special requirement for online purpose, of course. Okay. Moisture, Madhukan sir, moisture monitor online. See, in a transformer, normally it is done through sampling, but we have techniques through which we can do the online moisture monitoring also.
Good. Thank you.
Process to dry a power transformer, vacuum or LFH drying. Okay, offline process. So now this is another method which is very effective and very efficient. Okay, with this method you can really remove the whole moisture from the paper. So it is the most efficient drying system available. But the drawback it is very expensive. It requires a large outage, very big outage. It is only ideal for emergency drying, not for any continuous operation. Okay, its cost is very high for old transformers because it is applying vacuum to remove the moisture. So for old transformers, there is a chance that the paper which is holding on the winding, it will leave its place and go disperse into the environment. Okay, so it is a risk for old transformers to apply vacuum. It may damage the transformer further. Your DGA history is fully lost. You don't have a DGA history when you do the vacuum drying. So only you will do it only under the emergency condition where you don't have any choice. You have to do it, then only you will do it. Otherwise, we'll avoid that. And we need experience and well expert operator to do this operation. Okay. I'm really sorry. I request please don't put the self promotion posts. Really sorry that this is happening in this platform.
We have logged it, sir. Now you can continue, please.
Okay. So the another process for online drying is the online drying system. Okay, this is a system where we have three cylinders which are there, and oil is circulated through these cylinders. Okay, and these cylinders are removing the moisture from the transformer. Now this is a slow process. It is an online process. This system is permanently installed on the transformer, and it is removing the moisture from the transformer continuously 24/7. Now, if this the size we select according to the size of the transformer. If the transformer is big, we use bigger one. If the transformer is small, we use the smaller one. It ensures that the moisture in the transformer never crosses the critical limit. Never. Means this is the only system available which can actually maintain the moisture in a transformer at a particular limit. Like if you want to maintain it 2%, it can maintain 2%. It will not allow the moisture to go up. Whatever moisture above will be removed. Okay, with this system. It is a low cost. It is very cost effective. It is having a very good dry efficiency. It dries the transformer oil as well as the paper confidently 100% without any drawbacks. Okay. There is no DGA data loss in this particular method. This is the only method which can ensure your DGA data is maintained without any disturbance. There is no operator required. It is a permanent solution to be installed on the transformer permanently. It is safer for the transformer and having a very long life expectancy. Okay, if you install this, definitely your transformer life will increase by around 30% minimum. Okay. Disadvantage is it is not ideal for emergency drying. So if your transformer is having a lot of water already, so it is recommended to remove the water first and then put the online drying system, because this will not remove the water, large amount of water in a transformer. It is a slow process. It is having a flow rate of around 90 liters per hour. Okay, so which is very slow. So it is good for OPEX operational purpose, not for emergency maintenance. Okay, and the cylinders needs to be changed after they are saturated. So it is not a drawback. It is an operation. Okay, so we will just compare the three methods. If your transformer is very not so critical and your budget available is very low and your transformer is very small, you can go for oil circulation method also. If your criticality is very high, like the lot of moisture has entered into a transformer and it has become dangerous, at that time it is recommended to use the online drying system, this vacuum drying system. Okay, you have a budget, but if for some reason you are able to maintain, you cannot take a shutdown and you are able to manage running the transformer in that condition, then also it is better to use the online drying system. And then in the majority of all the other cases, in the green zone which is shown in the slide, are the places where you can use the online drying system. So this explains that in majority of the cases, applications, you should go for online drying. Only in some special cases, you have to go for LFH vacuum or oil circulation. Okay. Now we will see what is the online drying system. I will just give a brief introduction how it works. Okay. So there are various components, parts of the system. There are three cylinders. So oil is coming from the bottom valve of the transformer through a pump and the filter. It is being circulated in the three cylinders and then it goes back to the transformer. No rocket science, just oil aya and it is gone. Okay. The only trick is that inside these cylinders there are a few chemical known as molecular sieves. These are similar to stones. Okay, so when the oil is coming, the moisture is getting absorbed inside these molecular sieves. Okay, and then dry oil is going back to the transformer. It is going back to the transformer, dry oil, and then it is absorbing the moisture in the paper. It is coming back in the transact. It is again removing its moisture, going back to the transformer, removing the moisture from the paper, and then it is continuously circulating in this fashion. And thus it is drying the transformer very efficient. Okay, I hope you understood. So during the circulation process, the moisture from the paper is also removed. Okay, so this is the most efficient way to dry a transformer continuously. By using this system, you will never allow your transformer breakdown voltage to drop below critical limit. You will never allow the life expectancy of the transformer to go down beyond the natural aging. Of course, everything ages. So beyond the natural aging, you will not allow it to go down further. Okay. So this is a online drying system. Offline filtration and vacuum, you already know, I believe. If you are using a transformer, you must have done it sometime in your past. The main advantage of online drying system is one more, that it comes with an online monitoring system. So what online monitoring system does is it measures the moisture in a transformer continuously. Okay, sensors are installed at the inlet and outlet of the online drying system. Okay, streamer is dealing in transit, so at the inlet and outlet of the transit unit, and then it is measuring the moisture continuously. Okay, and then with the proper monitoring, it is providing graphs in this fashion, as you can see. So you can analyze the performance of the online drying system over a period of time. For example, in this is a particular example of, we have done an installation in Jakarta, where initially when we installed the transformer, the ppm was around 15 ppm. Okay, after a period of 1 year, the ppm came down to 6 ppm. Okay, and then if we analyze the moisture in paper at that time, so at the time of installation, the moisture in paper was around 3.2%. At the end of 1 year, this moisture in paper came down to 2.2%, which came within the safe limits. Okay, so this is the advantage and this is the benefit of using the online monitoring. Drying is one part, and monitoring main advantage is that we can do the proper analysis and that how your system is behaving or operating. Moreover, measuring the moisture in a transformer requires continuous attention. Periodic monitoring doesn't work effectively. Okay, so that is why the online monitoring. So we saw online monitoring and drying of moisture in a transformer. That was all we covered today. Okay, why the moisture is there, and from where it comes, where it is placed, how much is more, how to remove it, and how to monitor it. Okay, this was the session. So this is the percentage of moisture in paper, as I explained before. Okay, so from the wet transformer, we made it dry and safe. Thank you very much. If you have any questions, you can ask.